So that's a brief overview of the types of things that we do. Our intentions for the future is, well, we certainly intend to stay in business. We intend to remain in these traditional markets there, all of the types of scientific, astrophysical markets that I've mentioned here with NASA science missions. There may, over the last couple of years, there are differing views about the extent to which there's going to be a robust human spaceflight program in the future, but if there is, certainly we wish to be part of that human exploration as well. For NOAA weather satellites, we have a very large and increasing interest in the environmental science, business, Earth atmosphere, so we intend to be active in that market as well. In the future, we keep our eye on the possible emergence of new opportunities in the future. Again, over the last couple of years, there's been waxing and waning enthusiasm for going back to the moon or doing astrophysics from the moon, things like that. We will see. There's nothing at the moment, but if opportunities actually materialize there, we will certainly be interested in lunar science there. What's called exploration, this is the idea that we may send humans back to the moon or maybe to asteroids, maybe to Mars at some point, probably not in my lifetime. But that whole exploration science, what's involved in doing that, we actively investigate and participate in that as much as possible. Phenomenon called space weather. You think of weather as being confined just to the Earth's atmosphere, but the fact is that solar flares, the solar wind, X-rays, energetic particles, there's a lot of things that the sun does that it sends out into space that when they interact with spacecraft can damage the spacecraft, and if there are humans in space can be very detrimental to humans. And frankly, most people think that the real inhibitor of human spaceflight to asteroids or to Mars is going to be space weather, in addition to the issues about fuel and time and things there. But there's no known way at the present time to protect the health of human beings in space in the types of vehicles we have now for a long enough time to get to Mars and back and have them survive the radiation, the cosmic rays and solar flares and things like that. So that's opportunities for research in the future. How do we build better shielding, or what do we have to do to guarantee human survival in spaceflight there? What are called near-Earth objects. These are mostly asteroids. Some of them are comets whose orbits around the sun come very close to the Earth, close enough that some of them are what are called potentially hazardous objects, PHOs, if you like. And they would be hazardous if they got too close. And we're in the process of observing the sky to catalog them to see how many of these there are and to identify any that are potentially hazardous there. In-space operations, the whole infrastructure of doing things robotically or with humans, assembly and servicing. One of the magnificent things about the Hubble Space Telescope was it was designed from the very beginning to be serviceable. But that was all predicated on the existence of the space shuttle. We no longer have a space shuttle, and the new vehicles that are coming along don't have the same kind of capacity and servicing capabilities that the shuttle did. And frankly, the new spacecraft, like the James Webb, are being designed not to be serviceable in space. So if that concept of either assembly of big things or servicing of existing assets in space, that is certainly something that we have an interest in and will participate in there. Large launch vehicles are talking about building something called the Space Launch System, the SLS, which would be a Saturn V class rocket like we had in the 1970s. There are things about formation flying where you can have an observatory that actually consists of more than one telescope all working together, and there's plenty of other things as well. So the bottom line is that I have had a wonderful 26-year career myself so far at Ball, working primarily in astrophysics. Most of my colleagues, feel the same way. We enjoy what we do. We've been successful. I think that what we have built for the scientists has done its job. 2 of our guys have gotten Nobel Prizes using the instrumentation we built, so we're very pleased about that. And I think that things are going to be, wondrous in the future as well. So it's only 20 till 1, so we've got a little bit of time. I'd be happy to take some questions if you'd like. Yes, sir.
First, Will's going to pass out the quiz. Well, I guess we'll let you ask a few questions first.
Oh, come on, that was easy stuff. Yep.
This was very interesting.
Thank you.
And it seems to me that your company is what's going to be the backbone of what America needs to move forward in this new generation. But a couple questions from that. A, how much of what you do is classified? B, do you develop things on your own and then go out to NASA or Lockheed, or do they come to you and you build what they ask for? And what percentage of the materials that you build are really only in the United States versus subbing it out to China or some other place?
Oh, okay, let's see if I can remember three entire things. The first is that our business is about 40% civilian NASA, science mission type things, what I've been describing. About 40% is defense or intelligence related. Now, only a fraction of that is classified, but if you take, the business area as a whole, it's about 40% of our business is in the defense and intelligence, and about 20% is in the commercial realm there. So that's how that breaks down. You also asked, do we develop things ourselves and try to sell them? The answer is yes and no. I mean, we have to maintain certain capabilities. So we build our facilities, our clean rooms and our vacuum chambers, our test facilities, and we develop expertise in this thing, segmented optics, for example, with the James Webb. 20 years ago, we made some conscious strategic decisions that segmented optical systems was probably going to be a business area in the future, and we invested company resources in what's called internal research and development to basically support people to learn about it and to develop some capabilities for how do you control things like that. So we did develop some capabilities in-house. So when an opportunity came along, when NASA was soliciting proposals to build something like the James Webb Space Telescope, we were a credible player. We could say, well, we know about it. Nobody's ever done it before, but we know about it. We've been studying it, and we have smart people in our optics department and things like that. We generally do not develop hardware, flight hardware, and then try to sell it. We do have some products, like we build what are called star trackers, which are basically pointing and control devices. We do have a product line of star trackers, but we don't build them and have them in a warehouse and put it in a box and send it. When we have designs, and if a customer wants a star tracker, they can come to us and you can buy this one, that one, or that one, and they generally don't require a whole lot of new engineering. We said, okay, we'll build you one of those. And we'll build it fixed price because we know exactly what it takes to build it. Okay. So in general, though, most of what we do is what are called cost reimbursement contracts, where somebody hires us to use our capabilities and our people, our intelligence, to invent and build something new. So that's it. And what was your third question?
How much is building outside?
Very little. The big choice is make, buy, and it's do we literally build it in our own shops in Boulder or Broomfield, or do we subcontract it out? And again, there are strategic business decisions that there are certain things that are strategic capabilities that we insist on doing in-house to maintain that capabilities. And there are other things, let me give you an example. Optics, the material out of which the mirrors are made, there are many different materials. They can be made out of aluminum, they can be made out of beryllium, there are many kinds of glass, and there are many kinds of ceramics. And every mission has its own set of requirements and its own characteristics, and there's no one right answer. That James Webb is beryllium. The one going on Mars is glass and things. So, we choose the right material. So we